Hello, everyone. Thank you for your patience. I am just getting last minute people on board and into the group so that they can watch the live stream. Welcome to the Design Your Own Earthen Tiny Home Challenge. And I am so excited to kick this off. It's been building over the last few days. There's a lot of moving parts in the background, so bear with me if there has been any tech issues. Let me know. Ideally, you would have received an email this morning if you signed up. You could also just be hopping on here off the cuff and have not signed up yet. So we might just have to spend today getting everyone on board, and then we're rolling. So it's always a little bit exciting and a little bit nerve-wracking at the start, but we made it. So just for those who don't know, my name is Verena, and I am the main teacher at Earth Building School. Earth Building School is the teaching branch of our business Solid Earth, which we have had for coming up to 22 years now. So long time standing earth builders in Aotearoa, New Zealand, and working together with my life partner, Scott. So you might see Scott in the chat. He's here for tech support and to make sure that you can all hear me. So just making sure that works. Yes, is there sound? Sound is good. Yes, so that's always important for a live stream. Thank you for confirming that. And yeah, let's get started. Let's get it rolling. I'm just curious at this point to gauge a little bit how many people are watching this live and how many people will be watching this as a replay. So I will not be looking at questions or comments so that I can concentrate on presenting. And I will circle back to the comments and the questions at the end of the live stream. So totally going to answer questions all week. Also, if you're watching this as a replay, I will be monitoring comments on below the live stream. So answering questions all week. So you're not missing out if you can't catch this live at all. But please, in the chat, just let me know, are you watching live? Are you watching the replay? That also boosts the algorithm a little bit and more people see it. Helps us out. And yeah, we'll find out where you're coming from, like where you're watching from, and build the excitement of doing this in a big community. Over 200 people have signed up via the website, and if you haven't, I will put a link to that. So just say I haven't registered yet. If you're just finding this by chance, it is good if you can register for it, because that will get you into the pipeline to receive daily emails which complement the live streams. So the structure of the challenge, the way I imagine it to work, is like we'll be together all week. So for 5 days in a row, there will be these daily live streams at 12 o'clock noon New Zealand time. And that might suit some of you to jump on live, and it doesn't suit everyone because of work commitments and also because of time differences across the globe. But that's not really going to hold us back in any way, because the way we are structuring it, it works across time zones. You will also receive emails, and in those emails there will be a link to a recap page. So every time we do live streams, people go, oh, I'm falling behind, or I haven't caught something. And the live streams on the Facebook group sort of disappear down the feed a little bit, because you'll see there will be a lot of posting. People will start posting their designs and their questions. So it's quite lively and a little bit chaotic in the Facebook group. But in the email, you'll have everything in one place. So we're populating this recap page on a daily basis so that you don't miss out on anything. And the live trainings and the emails, or like the information in the emails, sort of go hand in hand, because there will be links to resources and suggestions for daily activities. yeah, so that's the logistical part of how I see this working. I'm very open to feedback as well if things are not working on the tech side of things. I'm trying to automate sending out emails, but that's not working 100%. So I am going back to sending out emails manually. And yeah, if you need anything, just let me know. Send me a message and I'll try and make this as smooth as possible. I would like to also say that I did a poll. So in the group, you might see a poll where I'm asking, are you a newbie to design or have you got design experience? And at the moment, the poll is 50-50, which is really exciting for me. And it's actually something that makes me really happy when I'm teaching is that we have a mixed group. So be this with free teachings or also in our paid programs, we always have a mixed cohort and it's very enriching. So I am trying to make the training as accessible as possible. So I'm trying to reduce the amount of jargon I use and, explain concepts in a simple enough way. And I'm also here to meet you where you're at your level of expertise and your questions and so forth. So feel free, really my teaching style is really based on questions. There's no silly questions and there's no, maybe there's too difficult questions, but don't be shy to ask difficult questions either. And I will respond to your needs. So I will try and really deliver what you come here to learn at your level, and I can totally hold both. So welcoming newbies to design, and hopefully you will learn a lot, and also welcoming those of you that have design experience, and I'm looking forward to exchanging ideas and learning from each other as well. So the only thing I would like to also ask from the group, especially at the start, there's a lot of excitement, and especially if you already have a bit of experience, there is this desire to jump ahead, and the structure. So, like the 5 days have a program, and each day builds on the previous day. So, my request is that we'll have a little bit of patience and that we just follow the program. And the reason for that being is that if all the questions come at once at the start, it can get quite overwhelming, especially for people that are new to design. So I will just see, the types of questions that come in, and then some of them I will respond to later, and some of them will be specifically to what we cover in the daily training. So inviting you to stick with the daily training and then see what comes next, and then we roll together through the program, if that makes sense. And today we're going to start off with wall systems. So presenting different types of wall system where we have a fundamental choice to make just for the sake of deciding what we're going to design. And the fundamental choice is between solid earth construction, so full earth, or timber earth hybrids. And the whole training is about that. So that will become clear, hopefully, by the end of the training. It's a nuanced decision, I think. So some of you already have an idea, what they would like to do. Some of you don't know anything about this at all. So I'll look at it through those few different lenses, and yeah, we'll take it from there. So with that said, let's start. And I'm just going to share my screen and take this off and this off too. And then what's happening here? Show on stream. I don't want this at all. Wait a second. Hide this. Yes, that's better. Those were my notes. It's not a teleprompter. I'm speaking off the cuff, not with a teleprompter, but I had my notes here, so it's good that that's gone now. I wanted to actually get rid of this. Just bear with me one moment so that we see the screen. Yes, that's better. Can you all see this? Can you all see this? Yeah, I'm sure you can. Just maybe give me a one or an emoji in the chat. And yeah, you have already started sharing where you're from. So the decision on the wall system will be, thank you so much for confirming that. The decision on the wall system will really, really encouraging you to make that decision based on your location. So you're sharing, some of you are sharing where you're watching from. Keep doing that also if you're watching the replay, so that I get a little bit of an idea, where in the world you are. So we are based in Whakatu Nelson, Aotearoa, New Zealand. Temperate climate. We are teaching with a focus on New Zealand building code and the New Zealand Earth Building Standards, but this information is useful, wherever you are, and the standards are actually internationally renowned and cited. So you will definitely get value from watching this, even if you're in another part of the world. And for me to know if you're overseas somewhere and what your local climate is like is useful, because then I can make the information even a little bit more relevant to where you are. So I see a lot of local people. I see quite a few people from Aotearoa. Wonderful. Let's get into it. So just before we start, a little disclaimer about the training. So and this is particularly relevant for New Zealand folks. We are not licensed building practitioners. So we are earth builders and have 30 years of experience in construction of earthen buildings. We have designed our own building. We produce building products. We support people in their building consent process. So we definitely have a lot of practical knowledge, design and construction knowledge that flows into this. But in the scheme of the New Zealand legislation and the licensed building practitioner scheme, we were not able to be assessed, and we were not able to get the certification for that. We have an exemption, being alternative. So just putting that out there, and also saying we're not really liable for your design. I'm going to impart information to the best of my knowledge, but obviously we don't have control over what you design and then build. So you need to take responsibility for that yourselves, and you need to check the legal requirements for your building. So this might be important to you or not important at all. I'm not going to judge that or comment on that. But whatever you decide to do, I really firmly believe that buildings should be designed to code, even if you don't require a building consent or you don't want to get a building consent. And the reason for this is that the building code actually makes a lot of sense. And the main aim of the building code is to keep occupants safe. So really encouraging you to, even if it feels daunting, to start looking at standards, and we'll be doing this in this training, so that you can build good quality, design first, and then maybe build good quality buildings. And this training, in these 5 days, is a very basic training on design. It is not a construction tutorial, because that's a much bigger topic. And we teach this in our paid program, but it is a longer process. And, there's a lot of things that can't be conveyed in 5 days. But I'm hoping that it will really, set a good foundation for you to start thinking how things go together. And I'm talking about, I called the design challenge a tiny house. So let's design a tiny house. What I'm suggesting for this training is that we design a tiny house. So a 10 square meter cabin. So not a tiny house on wheels, like a cabin style tiny house. and why. So first of all, if you're based in Aotearoa, these buildings do not require building consent or even LBP supervision for both construction types that I'm going to present. And it's really smart, I think, to start simple and learn the design principles and everything, really get your ideas flowing, because then it is easier to scale to something bigger. So you can scale it to 30 square meters, which in some places is still exempt. Or you can even scale it to something bigger if you want. So the 10 square meter cabin is a really good starting point, and it is a totally achievable thing. Uh, Theoretically, you could even design, or build a 10 square meter building without the plan. You can just go, oh, I'm just going to put something together, but it is much better with a plan. So we have learned this, I think, maybe the hard way. We have personally built quite a few small buildings. And at the beginning, we just sort of launched into it with like a rough idea. And then eventually we figured out that having a plan and really thinking how stuff is put together really simplifies everything and makes the process smoother. So in terms of designing, definitely like start small, try and keep up this week. You'll see there is a lot of moving parts even with a very small building, and then we can talk about what has to happen for you to either go into making this building a reality, like actually building it, or scaling the design into something bigger. So just a couple of words still on the legal side of things. So wherever you are, you need to make this investigation. What requires a building consent or what is exempt. So exempt means that doesn't require a building consent. And then you decide, what the situation is for you. And every region, every country will have different regulations. In New Zealand, we have this exempt building work. You can Google that and read up on it. So I'm just putting the wording on screen. I'm not going to go through that. There is actually even now has just come out a new publication about tiny houses in particular, and I'm going to put a link to that into the comments to the live stream after we finish. So that's just come out, or I've just been made aware of it a couple of days ago. So just the legal side of things, what is exempt, what requires a building consent, and that will allow you to then make an informed decision. And I'm not going to tell you what you need to do because that is up to you. At the moment, we're just talking about design. And as I said, it's important that you design to standards. And since we're looking at earthen tiny houses, I would like to introduce you to the New Zealand Earth Building Standards. So it's a set of 3 standards, and 2 are relevant for self-builders. For the design challenge, we're looking at the top one. So it's the 4299, Earth Buildings Not Requiring Specific Engineering Design. And these standards are designed to support owner builders, self-builders in designing full homes, but we'll apply the principles of this to a tiny house. The standards have been around since 1998, and they have recently been revised. The older version is free for download, which is really great. So wherever you are, but also if you're overseas, I would really encourage you to download this and have a look at it, because it is very common sense and it is very practical. And it really, like step by step, it lays out all the things you need to go through to design an earthen building. And the 1998 version is absolutely adequate for what we're doing in the design challenge this week. If you want to go for a building consent, in Aotearoa, New Zealand, you will have to get the 2020 version, which is paid. So that there's slight differences, just some few updates in terms of structural requirements, strength requirements, after findings of our recent bigger earthquakes. Nothing drastic at all. In actual fact, the earthen buildings performed really well in the earthquakes. Some of the historic buildings and buildings that were not built to code had a few issues. So there was an update there. The main difference with the new standard is that it has been extended. So there's more techniques in there. There's more sections. So there's sections on lime plasters in there now, even on straw bale and light earth infill and floors, which the 1998 version doesn't have. And I have been part of the revision of the 2020 standard. So we've been working on this as a group for quite a few years now, and it's been an amazing opportunity for me to work in a steering group and contribute to something that I'm feeling very passionate about. So in there, in the 2020 version, the main contributions that came from me were regarding low density Adobe and plaster finishes and floors a little bit. So that was fun. So just checking that everything is good. Yes, so if the video has stopped, maybe refresh. I think it's all running well. The other standard that is also free for download is the timber framed standards. So again, if you're in Aotearoa, New Zealand, this is, it's the law to use timber according to these standards. If you're overseas, it's also very common sense and easy to read. And you will require these standards either if you go and choose a timber earth hybrid, which the structure then would be timber, but certainly for your roof structure. So we will look at both the standards, the earth building standards and the timber frame buildings during the design challenge, and we'll go more into it on day 3 when we look at structure. But the links to both of these things, these standards, should be in your email. It will be on the recap page, and I will also put the links as a comment to this live stream after it's finished. So the fundamental decision today is we're looking at wall systems, and before we go into that, I just want to explain to you the purpose of the wall system. So walls have different purposes. Sometimes it's to keep you safe from the elements or to divide rooms and give you privacy, but the main thing that they actually do is like the building structure. And especially in a small building, like a 10 square meter building, all your walls are building structure. So what I mean by that is that the walls are load bearing. They support the roof, the weight of the roof, and they give structural integrity to your building. So all the 4 walls in your tiny home will be structure. So we're looking at load bearing walls. And for that reason, because they have to be load bearing, we can go down a couple of different routes. So we can either say we want to look at a load-bearing earthen wall, solid earth, or we want to look at a load-bearing timber wall that has earthen elements. And this, the earthen elements part with timber structure could also be adapted to Hempcrete. So I'll get into that in a moment. The solid earth walls, just based on, taking the temperature in the group, and when you're joining the Earth Building School Facebook group at the start, you're telling me your interest, and based on those answers that people give me, there's a lot of interest in Cob. So I will be presenting on Cob, and I will also be presenting on the Adobe brick technique, particularly the low density Adobe brick, which is innovation here in New Zealand, which we've been involved in since 2008. So I really want to present to you the option there. And just to give you a bigger overview, so when we're talking about earthen buildings, there is so many different techniques. Worldwide, there is just so many traditions, like historic earth building traditions, and according to different places, the climatic conditions and so forth, the craftsmanship, the resources, different techniques have developed. And we can roughly divide them up into 3 sections. So there is the monolithic solid earth walls, which monolithic means in one piece. There is the brickwork. So you have smaller units put together with mortar, or you have structures that are like a supported earth that is supported by a structure. So mostly this structure would be timber, or in some places it would be bamboo. And if you see again, for the sake of the training, I have picked, for the monolithic walls, I have picked Cob. For the brick, like the brickwork, I have picked Adobe. And for the timber earth hybrids, so where you have a support structure made out of timber mainly, I have we're going to touch on all of the options, because there's different ways that you can incorporate earthen mixes into timber buildings. So today, you're going to choose, fundamentally, you're going to choose, do I want to do a solid earth wall construction design, or do I want to design a timber earth hybrid? And there's different things that you can think about when you're making this choice. And sometimes people will be leaning towards a technique for whatever reason, but I always, when someone comes to me and says, like, which technique should I choose, the first question I ask them is, where do you live? Like, what is your local climate? What is your thermal the requirements towards thermal performance of your building? Because that's important in terms of comfort. And when we're looking at thermal performance of earthen buildings, there's always, any building for that matter, there's always this balancing of thermal mass on one hand and insulation on the other hand. So this is actually something that I'm still surprised how many people don't really understand the difference between thermal mass and insulation. It is getting more clear to many people, but I just want to explain it. So thermal mass is a heavy material which can store heat. So it's a little bit, you could compare it to like a battery. So if your building has a heat source, so be that sun coming into your building during the day and warming everything up nicely, or a heat source like a whatever heat source you have. If you've just got a building without thermal mass, it's basically you're just heating air. If you have a heavy material in your building inside that can absorb some of the heat, that's thermal mass. And the thermal mass then radiates heat out with a time lag. So it will give you some of this warmth back when, for example, the sun sets, or, your fire goes out. So that's the image of the battery maybe helps. Insulation, on the other hand, is like your jacket. It's the puffer jacket. It's the insulative blanket that is wrapped around the building to keep heat in. So it prevents heat loss by insulating the building. And typically, these materials that are insulating are very light and fluffy. So when we're looking at earthen materials, the earthen materials can do both. Not the same techniques, but with earth you can make very heavy mixes. So that would be your rammed earth, your cob, the traditional Adobe and so forth. Or you can make very light mixes. For example, you have a technique called light earth infill, or LEM. You would definitely, think about insulation when you're looking at straw bale, and also Hempcrete goes into this category because the mixes are very light. The low density Adobe is also insulation. So it's a much lighter mix. It's a brick that is still load bearing, but it insulates way, way better than the traditional Adobe block. So you have, in that brick, you actually have both. You have a balance of thermal mass and insulation. So just putting this here for you to start thinking, depending on your location, what do you need? And ideally, you have a combination of both, especially in temperate climates. Because if you're looking at this, so the gray thing here, this is from a government website, actually. So in the government website, they're suggesting concrete as thermal mass material. Concrete heats up fast and then releases the heat fast. So it is thermal mass material, but it has very different behavior to earth. It's much faster, and it's not actually as comfortable as earth. The earth heats up slower and then releases the heat slower. But the principle of the thermal mass action is the same. So you see, you have thermal gain, sunshine. Ideally, you design the building according to passive solar principles so that you can shade out high standing summer sun, but let in lower sun angles in winter. The solar gain heats up the thermal mass, the earthen floor or your earthen wall, and then at night that gently radiates back into your room. And then you see the orange thing, that is the insulation that goes all the way around the entire building. So definitely important to have insulation in your roof. You might want to additionally insulate the cold side of the building, or you have a structure that has insulation in the form of lighter mixes or insulation material. And that just wraps the whole building and keeps the heat in. So you see how these two components, the thermal mass and the insulation, work hand in hand. And it's actually something that I really feel is missing in a lot of modern conventional buildings, is like the building industry and the legislation really has caught on to the fact that we need to insulate buildings way better than we have in the past. But there is still this omission of thermal mass, which is a real shame, I feel, because if we have a really well insulated building, it's basically a little bit like like a chili bin or something. So sure, stuff is insulated inside, but you could just make it that more comfortable with the introduction of thermal mass. So moving on, another lens through which you could make this decision is if you're actually going to build the building, you're not just doing this as a design exercise. I would really encourage you to think along the lines of, your human resources and how that will happen, how the construction will happen for you. Just give me a moment. I just need to have a little cough. So the different techniques definitely have different requirements in terms of skill. So on the one end of the spectrum, you have the Adobe brick and the Cob techniques, which are very simple to learn. You can even learn this online. So we teach this online, and it is quite remarkable how we can upskill people even over distance. But you can attend a workshop, or you can get upskilled relatively easily. And then they also lend themselves for community efforts. So often there is working bees or longer sort of workshops that where people come together and actually build a whole small building. And that is very possible with the simple techniques like Adobe and Cob. On the other end of the spectrum, in terms of earth construction, you have the rammed earth, which requires shuttering and pneumatic rammers and so forth. So that is quite a skilled undertaking. It's not easy, and that's also reflected in the price of that technique compared to the other techniques. Your carpentry would also be in there. So I'm not saying don't do anything with carpentry, but if you don't have the skills or you don't have access to people with skills, you might have to employ someone. So that is doable, but that needs to be taken into consideration when you make the decision. And it's definitely feasible also to pick up the carpentry skills, and especially for smaller buildings, it is not that complicated, and it can be very satisfying to pick these skills up and to put something together with timber. So working with timber is absolutely wonderful, but you need more tools, and you definitely need to have the skills or develop the skills. And in between, along the spectrum, there is other things that then flow into your building, like the wall finishes and so forth, where you will need a bit of skill, a little bit more than just placing cob. So the plastering typically falls into that. But also, if you decide to build a timber earth hybrid, you have the timber structure, and then you have shutters and so forth. So there's definitely a little bit of work involved that is more skilled. And just tagging on to that is also the gear and the tool requirements. So the Adobe and the Cob often can be done with hand tools. You don't need that many tools for that. At the higher end is like the rammed earth. Again, you need the pneumatic rammers, and you're using tools to put the very heavy shuttering together. And along that spectrum, depending on what you're doing, you might require things like mixers, some carpentry tools, some plastering tools, and so forth. So depending on how much you want to invest in tools and gear, if you're going to build this building that you're designing, this is something you have to think about. Another way of looking at the choice between techniques is that the understanding how much moisture you're introducing into a building when you're building. So in earth building, there is wet techniques and there's dry techniques. And by wet techniques, I mean you're making an earthen mix. It can be different techniques. So you can have cob, or you could have a light earth infill, even earthen plasters. You're making a mix that contains quite a lot of water, and you're placing it straight into your building. And then you have to wait for that water to evaporate and for the mix to dry out. So that's wet techniques. On the other hand, you have the dry techniques, where you basically produce an earth building material away from the building. It dries out, and then you're placing it into the building dry, or with minimal water. There's a little bit of moisture in the mortar. In rammed earth, there's a little bit of moisture, but overall, you're not introducing that much water into your building, so the whole thing dries out much faster. And that affects the logistics, of how your building project flows, how soon you can move in, and so forth. And it affects, depending on the technique you choose, it really affects the drying times of your building. So when you're looking at things like Adobe blocks, Hempcrete, door, and so forth, even things like straw bales. Straw bales are installed dry, but then they're plastered, so there's a little bit of drying time in the plaster. These techniques typically, don't take that long to dry out, so up to 2 months. If you're going into wet techniques like cob or light earth infill in your timber earth hybrids, you're looking at much longer drying times. So it can be upwards from 2 months all the way up to 5 months for cob, depending on the wall's thickness. So you need to take this into consideration when you think about logistics of the building. And when you start building, that you're not building a building that has to dry out over 5 months, in autumn. The timing really affects things. So ideally, you want the building to be drying out in summer. And it is important to allow the building to dry out in a timely fashion, because otherwise you might have issues such as mold formation, or even it's not so nice to be in a damp building, and you certainly shouldn't move in before it's dried out. You can't do the wall finishing before it's dried out, and so forth. So just a little note on the Hempcrete, why the Hempcrete and the LEM is comparable in technique. So you have a very fluffy light fiber that is mixed with a binder and then put into shutters. And the LEM and the Hempcrete both work in the same similar way. The difference with Hempcrete, like the commercial or like the Hempcrete that is usually done, is that it has mostly a line binder, or in Aotearoa now there's the development of a geobinder. It's a binder that undergoes a chemical process and binds faster. When you're mixing earth building techniques, you usually don't have a chemical set unless you add stabilizers, which we don't do and we don't recommend you do. But for the Hempcrete, you would have this chemical set, and that's why it goes off faster and dries out faster. I'm actually really hopeful that with time, people will start doing Hempcrete with earthen binders rather than lime binders. And it's a discussion for another time. I know that there's people that are very passionate about Hempcrete. I have a nuanced viewpoint on Hempcrete and questions about it, but I really feel that the combination of hemp, shiv, and clay binder would be very wonderful once the hemp affordable, because at the moment it's not, at least not in our country. So that's the drying times. And then you could think about other things, other cost considerations. The owner, if this is something that's important to you. And when we advertised the tiny home challenge, we were definitely talking about affordable buildings and owner builder contribution to that. We're very passionate about empowering people to be able to do this. The owner builder effort can reduce the cost of the building considerably, but depending on the size of the building, your wall system is not the thing that costs the most in your building. So for tiny homes, it definitely makes a big difference if you build yourself, and depending on the materials you use, if you can source secondhand materials, or if you can mill some of your own timber and so forth, that will all reduce costs. For bigger buildings, you have to do a proper cost analysis of everything, because we found that the type of wall system you choose, you can't say this wall system is cheaper than this wall system. It really depends on a few different factors. So on day 5, we have dedicated the whole training towards quantity surveying and cost analysis, because it's important, and it might steer you away from a certain technique that you might have wanted to choose because you like it. You like the sound of it, and then you're crunching the number, you might not want to go down that path. So it's good to compare different types of wall systems. It's good to do the math on it, and it's good to think about your resources, both money-wise, people, materials, and so forth. And you might want to go through this design process with both wall systems. But for today, the invitation is, just based on what you've learned today, choose one and then roll with it. And then if you want to compare it with the other one, you can go through the process again. And last but not least, the environmental footprint of the building does matter, especially in this day and age. So I really encourage you to see what is locally available, to reduce transport of materials, to really look at embodied energies. Sometimes there is requirement for steel and concrete and foundations, depending on where you are. Look at that and then weigh it up with other materials. Look at things like timber treatments, and try and choose materials that are non-toxic, both for yourself, for your own health, and for the health of the environment. So these are all things you could take into consideration. And I'm just going to leave this, a couple of words about costs. So the timber, and this is statistics based on New Zealand. So our own government has put these figures out. The timber has gone up considerably in cost. So unless you can maybe source local timber and get it milled locally, which is beautiful, you might really want to look at the costs and how these have increased. If you're leaning towards a timber earth structure, and it's not just for the structure, it's also for the cladding and all those things. So it can add up. And the costs have gone up, but also there's a bit of a supply chain problem in the supply chain sometimes. So sometimes it's hard to get hold of the timber, and it can hold you up. So in times like these, I think the earthen materials and the solid earth wall systems could really shine and kind of make you independent of that supply chain, of the timber supply chain, unless you have a local supply, which many people, especially if you have time to look around, that's a beautiful thing, to look for local timber. So now I'm just going to talk you through the different techniques, starting with the solid earth wall and the Adobe brick technique. So I'm mainly talking about low density Adobe, which is a lighter mud brick, which is still, able to support the weight of the roof, but this can be adjusted to any type of Adobe brick. So if you're in a hot and dry climate, for example, you would definitely still use a traditional Adobe brick. If you're in a temperate climate, you would go to a low density Adobe brick. So it is load bearing, it's strong as you can modify how much insulation and how much thermal mass the brick has depending on the mix. You can use a very wide range of soils if you're making your own bricks, so it's suitable for lots of different places and soil types. It's very easy to learn. It's covered by the New Zealand Earth Building Standards, and it is a very simple technique. So it can be as simple as just making a mold out of wood and just hand casting bricks. Minimal gear and tool requirements. You're drying out small block, you're bite-sizing your building. Basically, you're drying out these smaller units, storing them. They shrink while they're not in the building and do all their thing. And then when you put them in the building, the construction is very fast and the drying times are short. There's minimal shrinkage in the building. There's still, whatever type of Adobe brick you choose, there's still quite a substantial amount of weight in those solid earth walls, so they require good foundations. And the walls are thick. So to be load bearing, they have to be a minimum of 280 millimeters, so 28 centimeters wide, so about that. They can be wider. So when you're designing, you're taking the width of the walls into account. And the timeline for Adobe, that's, the logistics of that is you're making a mix, you're making bricks, the bricks dry out, you stack them away. At the same time, you can do your design. And then when you're ready to build, it's fast. You're laying the bricks and they dry out fast, and the finish can be done later on. So you're laying up your walls, and then very soon after you're putting up the roof. So it's very fast and efficient. And for a small building, the whole process can be done over the warm season. For a bigger building, it would typically be split up over 2 seasons, 2 warm seasons. And comparing this to Cob, so that's also a solid earth wall. It's the same thickness, minimum 280 millimeter thick walls. It also requires good foundations because it's definitely heavier than the mud brick. Also load bearing. Sometimes people put up a post and beam structure and put the roof up first and then cob around the post so that they can work undercover, because the working times are longer. So, with the mud brick, you can just theoretically, have a good window of weather, 2 weeks, lay the walls, put up the roof. The cob, it's, you're looking at months. So some people choose a post and beam structure. Also, a wide range of soils is useful. What you're doing is you're making a cob mix. So you're introducing straw and sometimes aggregates like coarse sand or crushed rock. So there's a bit of making the mixes is a little bit more labor intensive, and you're also often having to add slightly more expensive components depending on what you have available locally. It's easy to learn. It's also covered by the standard. Um, because it's installed wet into the building, you need to allow for shrinkage and settlement. So that is something that you think about in the design, and also when you're developing the mixes, you have to control shrinkage with the right mixing, and you're testing for shrinkage, and you're having to let everything shrink and do its thing before you put, for example, windows in, because if the wall shrinks down onto the window, it might not be so good. So yeah, there's similarities to the Adobe block, and then there's distinct differences, especially in the logistics of the timeline and the required time during construction. So just to show you that, you're mixing the cob mix, and then you're freeform placing the cob in the wall. You're typically going up layer by layer, and you can only go in layers as high as they can self-support, so before they start slumping. So it's a little bit like when we were in the pottery class, where you make the sausages and you sort of build up with the little sausages, so just on a big scale. And between the lifts, so the little sausages are called lifts in the cob construction. So between these lifts, you have a little bit of waiting time for that lift to firm up enough to then support the next lift. So definitely the building process is much slower than laying mud bricks. And then you build all the walls. Sometimes there's a little bit of trimming depending on how tidy you've laid the walls. Some people use shutters that sort of self-trim. And then there's quite a substantial drying time, which can extend over months. And in that time, the walls have to be covered. So there's either a roof structure that is required, which you can't totally install before the wall is totally, it's dry and strong, or you cover the walls with tarpaulins or plastic till they're dried and protect them from the rain. And then later on, you also do the plastering and finishing. So it's much more drawn out. People go like, why would I make a masonry, like a block, like a mud brick? It's like, isn't that like double handling? And I'm saying, no, like it's kind of the same thing. You're just picking up a blob and then placing it wet, or you're picking up a blob and making a brick and then putting it in faster. So it's not necessarily faster to build straight in place with cob. In actual fact, we find that overall the Adobe technique is a little bit faster. So just the logistics are different. And to show you some images of this, so this is a mud brick place that we supported some students in building, and it's a 30 square meter building, this one. And they made the bricks themselves. And then when they were ready to lay, I think this building took them 3 days to lay all the bricks for the walls, and then they put up the roof, and they also finished the the exterior with a lime plaster, interior with an earthen rubbed finish, and they started laying an earthen tile floor. So all the materials pretty much of the interior were just earth installed in different techniques. It was very neat. Cool. So I'm just now pivoting to the other type. So it's a timber earth hybrid construction. What I mean is there's a timber structure and there's earthen components that are incorporated into the timber structure. And one of these earthen components could be daubed earth. So wattle and daub is a technique where you have a lattice work of some sort. So you're applying an earthen panel to usually to the inside of your building. It can be on both sides if you can protect them from the elements on the outside, but it has a certain weight and it needs a good support structure. So something is attached to your timber frame that can take the weight. So there could be horizontal battens or trellis or bamboo or whatever. And then you're applying the clay over that. And it's heavy, so it's got good thermal mass, but it's a thin panel, so it doesn't have good insulation at all. It has some thermal mass properties, so it's useful as something that gets retrofitted into a building, but you definitely still need insulation. Because it's not so thick, it dries out fast. It's useful for interior walls. And it's also really nice, a nice technique if you want to have creative expression or sculptural elements in the building. So in a tiny home, it definitely could look good. You know, you can do little recesses or even inbuilt shelving and so forth. And you can bring that sculptural quality of the cob, because it's definitely like it's basically a cob mix. So it's an earth that has got a fiber in it, and you can play with it. So you can bring that into a timber frame building. So the daubed earth is a really good option if you're going for a timber building and you want an earthen aspect to that. A very refined example is the traditional Japanese walls. They are typically made from wattle and daub. So they build these walls up in different thicknesses. The interior walls are often thin, and they go over a lattice work of bamboo and then finish it with very fine, beautiful earthen plasters. So that's a nice example of wattle and daub. It also exists in the Americas, in places where walls, are often built around bamboo. The two materials go together really well. It's also, you don't need very thick walls. In places where you need insulation, so if you went into a timber frame structure and then you are bringing in earth as infill, as insulation, you want to work with a very light and fluffy mix. So you can have your light earth infill mixes made from all sorts of different lighter additives to the clay. So it could be fibers such as straw or rice husks, or it could be wood shavings, wood chip, sawdust, and even mineral light aggregates like pumice. The way that light earth infill works is you have a timber structure and then you have shuttering. And I'm just seeing, what is a shutter? So a shutter is boards that you attach to either side, and then you fill between the shutters, so they are just holding the mix in place while you're placing it, and then later you take the shutters off and the wall stays in place. So for light earth infill, you definitely need shutters. You're filling the light earth mix between between timber elements. You need to, shutter, like detail this properly for the light, like specifically for the light earth infill, and the standard shows you that, like, and I can also show you photos or diagrams of how that is done. For the design process, it doesn't matter so much. This is construction. But what you need to understand is that when you're going for a timber earth hybrid with light earth infill, the light earth infill pretty much only fulfills the function of insulation. So light earth infill is comparable in a way to Hempcrete, So the crossover is quite clear there. So you're putting this in as insulation, and you're introducing. So you're putting in this, and like it's slowing down the building. It's prolonging the construction time because this has to dry out, and then it has to be plastered. So typically timber earth hybrids are a little bit more complex because you have a timber structure, then whatever you choose, you have a light earth infill or a wattle and daub panel, something. On the exterior, still needing a cladding, and on the interior, still finishing the surface of the wall in one way or another. Usually you're applying an earthen plaster. So you have the situation where there's a lot of material changes, and also where there is multiple layers and drying times between those layers. So the detailing and the thinking around all of that is a little bit more complicated. And just to show you again, to compare it, so that you can wrap your head around it, when you do an infill with plaster, so you have the timber structure erected first, including the roof. Then you're infilling, which is equivalent to putting in insulation. This has to dry out, sometimes for several months. So it's really important to do this at the right time of the year, and to ventilate the building because you want it to dry out. And then later you're plastering. So this can be a lot of work. And again, people say, but the infilling goes fast, It's like, yes, it goes fast, but it's only one part of the building process, and it's actually just the equivalent of filling in insulation. So keep that in mind in terms of the timeline. There's lots of other jobs that have to be done. And to show you this on a building, again, that's a 30 square meter building that we were involved in. The people here milled some macrocarpa on site, so they had all this beautiful timber, and they had a lot of sawdust and wood shavings as waste from the milling. So we made the light earth mix from the wood shavings and the sawdust and earth that was also dug on site. So all the materials of this building, apart from the roof, the sheet iron for the roof and the foundation, came from within 50 meters of the building, which was amazing. The exterior we then finished with lime plasters, and we did a plaster artistry workshop on it, which was a lot of fun. So that's why you see the colorful artistic details on the outside, and on the inside we did the same with earth. So we did the plaster artistry with earthen plasters, and different students did different wonderful things in the panels inside. So this is just to give you some ideas of how the timber earth hybrid could look. And another initiative that is a timber earth hybrid is the Posi. So it's developed by a local designer here in Whakatu Nelson called Mark Fielding. He was very inspired by the garbage warrior idea. So he wanted to build these little cabins out of totally reclaimed materials, mainly shipping pallets for the structure. And he actually used waste styrofoam sheeting that was, it was from wrapping appliances. So he went and got styrofoam out of the waste stream for insulation, which, I like the idea of recycling, but it wasn't a very pleasant material to work with or for the interior climate of the building. And he then used a recycled carpet as the interior lining and a clay paint over the recycled carpet, and reclaimed materials for cladding. So he calls it the posi. Um, he has an ebook up online where he shows the process, because he actually developed this as a panel system, and the actual pallet panels were stress tested. So I think he even got a building consent with this system, and he scaled the system up for bigger buildings. We inherited a part building from him, a little posi, and didn't like the styrofoam at all. So we packed the pallets with light earth infill and then finished inside on with different things. So either earthen plasters or the carpet with earthen paint or a Wattondorf panel. And it works wonderfully. So yeah, a very nice little building with the earthen materials rather than the styrofoam. So at our place, we have 3 different small, tiny buildings in different techniques. So we have 2 timber earth hybrids, and we have 1 solid mud brick tiny house, and soon we'll have a 30 square meter, a bigger building that is going to be our teaching space, our little tiny campus, which we also built from mud bricks. So we're comparing the 2 wall systems, and we're definitely leaning a little bit towards the mud brick, but I'm really trying not to skew you in any way, and just present the rationales that we've gathered over the years to let you make a decision. And the look is important too. So some people actually really like the solid earth aesthetic of the solid walls. Some people like claddings. I would suggest that you choose the look, to feed your soul, but that the look is not the only thing that determines which technique you're using, because the main thing really is the resources and your location. And there's definitely a scale of cool how the different techniques are perceived. So the rammed earth aesthetic is beautiful. It's cool. Hempcrete goes into a similar thing. It's cool because it's hemp, and it's also cool because it's got the strata. I sometimes sort of jokingly or not so jokingly call Hempcrete the gateway drug to natural building, and I hope it will, bring lots of people into the natural building fold, and then that we start looking at other ways of doing Hempcrete with earthen binders as well. So putting it out there, like the look is definitely important. That if you really feel passionate about something, it's great, because the passion fuels you to achieve your dreams. Yeah, let's discuss things in the group if you're still questioning which technique you want to choose, and I'm very happy to have these conversations. I'm just going to show you a couple of other things from our own little buildings. So things you can do. This is the timber earth hybrid construction, timber frame, light earth infill, earthen plaster, and we have a detail where we around the bed we have reclaimed old wood. I really like the material changes in the timber earth hybrids. You can do really beautiful things. And on the other hand, this is the mud brick cabin with the Adobe tile floor. So it's very much that brick aesthetic, very solid feel, very nice thermal performance in this building. Yeah, and quiet. So they're just different, and it's nice to be able to compare them. And another, just before we wrap it up, really important when you're thinking about building or designing and then building is to build safe buildings. So both the solid earth construction and the timber earth hybrids, they have certain rules you have to follow for them to be safe. And what I mean by safe is the forces of nature on the building. So in places like Aotearoa, New Zealand, where we have earthquakes really affect buildings, and the heavier the building, the more you know the damage to life could be. So that definitely needs to be taken seriously. Water is another one. So water can affect any kind of building. Typically, people think, oh, like earthen buildings are more prone to water damage. And sure, you don't want them to be flooded and inundated. You don't want rising damp, water runoff, and so forth. But you don't want that on any building. So especially your timber earth hybrids, like with earth, if earth gets very wet, eventually it disintegrates and it's not a good look. With timber, if you have moisture, you have rot. And typically, when we look at historic buildings in our country here with a temperate, humid climate, the earthen buildings actually have a much longer lifespan. So in any building, you want to really make sure that the detailing is up to scratch so that you keep moisture out. And wind forces are a really big one wherever you are on the planet. This is only going to become more with global climate change. So really making sure that your structure is strong enough to stand up to wind, that your bracing, the stiffness of the building is up to scratch, and that your roof doesn't lift off. And we'll look at that in more detail on day 3 when we look at structure. So taking this seriously is important to us. There's a lot of examples of natural buildings, especially small, sort of experimental buildings or buildings without consent that don't comply, and they're not built in a safe way. And it is really important to us as a school to promote good building practices, regardless of whether you're applying for building consents or not. And just to give you an idea, we're talking about seismic areas. That's areas with earthquake, red here, and you see areas where there's earth building. So there's a lot of overlap, and earth building gets a bad rap in earthquakes because they collapse, and New Zealand is at the forefront of earthquake safe design with the earth building standards, and that's why we're internationally cited with these earth building standards, because we have a very good system that is practical and safe. So just to show you that again, it's this one here, 4299, 1998, and you'll have the link to this in your materials, and I'll pop them into the comments as well. And you can also just Google it and find them, and they're free for download. So really useful. We have students from many different countries that have been using these standards to design their own buildings, and in some places even convince their local authorities about the safety of the buildings, and to educate and get earth building updated into like more modern requirements for buildings. So really encouraging you to check these out. And we'll also need this the timber framed building standard for the roof structure at least, or if you're going into a timber earth hybrid for the walls. So get both for the sake of the design challenge. Download them so that you can have a look at them. And that brings us to the end of today's training. I would invite you into some assignments if you want to take part. Some of you will just consume this for information. If you're starting to design and you want to be part of the design challenge, like in real time, today I would suggest, based on what you've just heard, what you've learned, choose a wall system for your tiny house design. Make a choice, If you don't know what to choose, just choose something, because you can always repeat the process for the other type and then compare notes. And then, like having the restraint will actually focus you, and it will just make this design process possible. So choose something today. Don't overthink it if it's complicated. Ask questions, and then share in the Facebook group or on the page what you've chosen and maybe why, if you want to share that. And also inviting you to keep sharing the challenge. So the link to the challenge is also below. It's challenge.earthbuilding.academy so that other people can jump on. It would be amazing. Yeah, we'll just bring people into the fold all week and see what you all come up with. And I'm excited to start this rolling. So I just look at the chat for a moment and answer questions for you. Hi. So let me have a look. So you can just pop questions into the comments, and I've got them all here. It's hello. It's so nice to see people from different countries and locals and people from up north. There was a question, where is the poll? So you don't have to fill in the poll. It was just like, do you have experience or not experience? It was just for me to take a little bit the temperature in the group. You can be watching this thing now in two places. Either our Facebook page. The page is our professional presence on Facebook. So on the page, you can only comment on my posts. We have a group as well. So the group is called Earth Building School. And I would warmly invite you to join the group, because the group is where you can make posts, interact with each other more. The live stream is streamed to both places. So wherever you are on the page or in the group, you'll see this, but the poll is in the group because the group is, if that makes sense. So many people telling me we're Cambodia. Wonderful. So excited to have you all. Papua New Guinea. Hi, Stephen. So the question was, does Hempcrete provide both thermal mass and insulation? So just a little disclaimer, I'm no Hempcrete expert yet. I was really into Hempcrete about 20 years ago. So my heritage is European. I'm originally Swiss, and definitely was excited about Hempcrete back then already. And Hempcrete can be done with a range of binders. So very exciting to try mixing hemp shift with clay binders. At the moment, hemp shiv is expensive in New Zealand. The binder is expensive. So we are not that interested in going into Hempcrete, mainly for cost reasons. Once if the price ever comes down, we will go into R&D to look at clay binders. To my knowledge, we're looking at a very light material. So no, it doesn't have that much thermal mass. It mainly is an insulation material. It has some thermal mass. So in a way, it's comparable to the low density Adobe brick, which we produce and we teach people to make themselves. The low density Adobe is just doesn't sound as cool as Hempcrete, but it's cool too. It's just made with wood shaving instead of hemp shiv. So it's totally strong. You can, it's a very comparable material actually. So, and the insulation versus thermal mass equation depends on the actual mix. So the heavier the mix is, the more thermal mass it has. The lighter the mix is, the more insulation it has. And with Hempcrete, you're looking at pretty light mixes, so more insulation. And the two, Hempcrete doesn't exclude earth building. So if you want to bring some thermal mass into a Hempcrete building, you can just retrofit an earthen panel or an earthen plaster or something. So, if we need to talk more about thermal mass versus insulation, we can ask questions about this because, it's not a black and white answer. It's a spectrum and it's a balancing thing. Um, thank you. Interested in hearing more about on Hempcrete earthen binders? The cost and caustic nature of the lime was something we struggled with on our bathhouse project. Exactly. So with the Hempcrete, you are working with lime binder or a geobinder. So in Aotearoa, New Zealand, the geobinders are being developed. I don't actually know what is in the geobinder. It's still something that chemically sets. It's more it's more skin friendly, so it's not as caustic as the lime. It might have other drawbacks. It's in development, so all of this is still in development in this country, and that actually leads me to just saying something about transferring R&D from other countries, or even what people do in construction in other countries, to Aotearoa, New Zealand. You really, when you do this, I understand the excitement about new techniques. I have it too. The R&D aspect of it is very exciting, and it's actually one of our core values in the school to encourage R&D. It has to be done properly with proper testing, and it has to respond to local conditions. So in New Zealand, we are dealing with earthquake, wind-driven rain, and the earth building standards actually, there's the other standard called materials and construction, and there's a testing regime in that allows for R&D and then strength testing, durability testing, and so forth. So that's how we developed the low density Adobe block. Was going through a really a testing regime. We also worked with the Auckland School of Engineering and did full scale testing for earthquake. It's not such a simple process, but it can be done, and we will definitely look into that with earthen binders. But at the moment, the cost is just prohibitive. So, like a bag of hemp shift is more expensive than a brick, like same size. So why? If you still have to get the binder and then make it, and it's why. So low density Adobe, it's just the it's kind of humble and not so flashy, and it doesn't have hemp in it. We could make probably low density Adobe blocks with hemp, but wood shavings are a waste product and they're just way cheaper. So that's why we're using wood shavings. I think I explained what a shutter is. I will pop an image of a shutter into the group, and then you can see what I mean. Will you cover the floor foundation options? So, short answer, not really. No, we're looking at design. So we will talk a little bit about a couple of different options for foundations, and from a structural point of view, and options. Depending on where you are. We have limited options in New Zealand because of earthquake. The floor is a different thing. So the whole thing about how to build it is not part of this training because, like we've packed it into a 3-month training called Earth Building Academy, which is launching next week. And even there, it's really packed in. So 5 days, like our trainings won't allow us to go into construction. It will allow us to have a really good look at different aspects of design. And by design, I don't necessarily mean how it looks. So it's how it's put together. So it's a really good starting point. And if you have concrete questions about either floorings or foundation, ask it in the Earth Building School Facebook group, because that's what the group is for. Like we're exchanging, we're in there teaching regularly, and other students also often hop on and answers things. So really encouraging you to engage in that group. Can you explain the difference between traditional Adobe, low density Adobe, and compressed earth blocks? Great question. So traditional Adobe is a mud brick. It's made of subsoil, so the clay soil dug from nature with water, maybe a little bit of fiber, often, not that much. It's made into quite sort of, it's a little bit like porridge, so quite a sticky, sloppy mix, put into a wooden mold. The mold gets pulled off straight away, and then they get air dried, sun dried, puddled mud bricks. A compressed earth block is more like, it's not like rammed earth, but it's similar in a way because you're working with quite dry earthy material and you're pressing it, and often a cement or a lime stabilizer binder gets added to the compressed block. It's very compressed, so much heavier than even a traditional mud brick, very square, often cement or lime stabilized. These are the two blocks that traditionally are used in earth building. The low density Adobe is innovation from New Zealand that has taken the Adobe system, which is super simple, and adjusted it to still be, everything is put together the same as with a traditional mud brick, but the low density Adobe block is much lighter because a lot of wood shavings have been added and cellulose. So it doesn't have any concrete in it, cement in it, no lime. It's not chemically altered. The only thing that has changed is that the weight has been reduced, and reduced weight means better insulation value. So I will pop a video into the group where we show how the low density Adobe block is made. It's innovation. It's been going on, being developed since 2008. So there's buildings that have been built with it. It's been strength tested, all the things, It's wonderful innovation. And I really hope that it will become a little bit more well known, because the traditional mud brick and even the pressed brick, they're very heavy and they don't perform that well thermally in temperate climates. They're great for hot and arid climates. They're good if they're additionally insulated. But the low density mud brick does that without additional insulation and at the same strength. So good for temperate climates. So there's some questions about Hempcrete and natural binders. We're just not there yet. But we're not there yet. The hemp shiv is too expensive. But anything you can do with light earth infill, you can do with hemp shiv. Like the light earth infill as a technique doesn't prescribe what kind of fiber you use. You can use hemp shiv, you can use wood shavings, you can use straw, you can use sawdust, you can use pumice. So light earth infill is basic. It just doesn't sound as cool as hempcrete, but you can do light earth hemp light earth infill. I'm curious what a carpet lining is. So the carpet lining is basically using recycled carpet and nailing it to the timber frame with the hessian side up, facing towards the room, and then plastering that surface with earthen plaster. So when it all dries, it basically turns into a board, and it's a nice cheap, it's a nice way of using a recycled material and lining your building. Can you build your timber frame and roof and then put your Adobe walls? Yes, you can. So if you were to do that, you wanted to already have the roof up, then you would be fitting your Adobe blocks around the timber frame, and it's quite fiddly. So that Adobe technique doesn't need timber poles. Like, it's load bearing. It's a simple system which doesn't rely on timber in the walls at all. The cheapest way is to just build your Adobe walls and then put the roof up. But if you want a roof up already, then you would build a post and beam structure, so posts, and then you would be laying your mud bricks around that. A little bit more expensive because you're doubling up, you're having posts and you're having the Adobe, and then it's more cutting around the timbers. But it's nice to have weather protection. So again, from a logistical point of view, that's something I would ask you, where are you based? How much rain do you have, and then you make the decision whether to put the roof up first or not. Do I have a sense of how Hempcrete compares with Timbercrete? No, I am not into Crete. So as a school and as a building company, we use raw earth. So we're not mixing stabilizers with anything, with earth or other aggregates. So it is a whole different school of thought, and it's a science in and of itself. We have good reasons why we don't mix earth and either lime or cement. We're not into Crete, even though Crete sounds cool. Yeah, because it is a bigger discussion why we don't do this, but it's particularly for environmental and breathability reasons we don't mix. So I'm not the person to ask so much about stabilizing and comparing stabilized materials. So for those that don't understand what I mean with stabilizing means that you're adding binders that chemically alter the mix and chemically set. So your concrete, your lime, or geobinder. Short-term rent a tiny home made with refrigerator lining. Acoustic terrible, amplified all noise outside. Wow, interesting. Capture and lost heat. Cheap and unhealthy choice for design from designers. Yes, that's the thing. Just because it's a reclaimed material or a recycled material doesn't mean it's a natural material. And my background is in design, so architectural design, and building biology and building ecology. So the building biology is the impact of buildings on the inhabitants, on the health of the inhabitants. And there's definitely good materials and materials that are not so good. So even if they're not toxic, they have bad acoustics, or it's not breathable. There's different things that affect our well-being in a building, and natural materials just take it away. They shine in terms of how comfortable and healthy they are if they're installed in proper ways, because they're natural. The building is like our third skin after the clothes, and you can feel the difference. So there's already someone saying Cob, I think, due to the limited covered storage to dry Adobe bricks. I need to check out now for another appointment. Okay. Yes. So the limited storage for Adobe bricks. If you're in a place where there's a lot of rain, can be an issue. What we do here is we just, once they dry, we stack them on pallets and then we wrap them in plastic. And we don't have a shed. We have a mud brick yard where we produce them and then we store them in the field. So the storage, would be nice, but we don't double handle them into a shed and then back out of a shed. They just wait there till they're ready to go somewhere. Is it possible to get the slides? I have to think about this because there's a little bit of copyright thing. I'm probably inclined to say no unless you enroll as a student with us, a paid student, and we can put it behind, we can put it on a course platform. Yeah, just because there is information from the New Zealand Earth Building Standards, and I do have a license to teach with this, but I don't have a license to give it out. So yeah, I think that's the safe answer to cover my back. Someone picked up that I didn't explain the cement plaster. So good paying attention. Cement plaster, so that was in the slide about the damage. Cement plaster categorically is not compatible with earthen materials, full stop. So there is the case where cement plasters have been applied either in renovation, there's cement attracts moisture and traps moisture, and it's also very rigid. So it's not a good thing. It's not breathable enough. And we actually, like the New Zealand Earth Building Standards say, no cement. Anything that you apply to an earthen surface has to be breathable enough. So the least breathable that is still possible is a lime cement plaster. I would always recommend a pure lime plaster because the breathability and also the flexibility of the plaster is much more compatible with the earthen material. And we see this in historic buildings or where there have been repairs. If there was cement plaster, there's always a moisture problem behind it. So really needing to stay away from that. Someone put the link into the me winning the tradeswoman of the year. That's sweet. Yes, I did. Yeah. I still blush about it. To have an idea of cost, how much would dry Adobe bricks cost to build a 10 square meter tiny house? Let's park the cost question until day 5 because we have the whole quantity survey and then we can answer that in detail. And like the material for the wall is just one part of the cost of. I'm not quite sure about the comment about don't you use lime as plaster in bathrooms? Yes. So, just wanting to explain, like I'm bashing the stabilizing a little bit. I'm only talking about mixing lime or particularly cement actually into earthen mixes. Cement is used in concrete foundations. It's great material. It's strong as, it's good in the ground. Good, it's high embodied energy, but it's a good foundation material. Just if you look at it from the point of view of strength. So definitely using concrete components in the buildings. Same with lime. Lime is great. Lime is great for lime plasters. You can use exterior lime plasters or you can make interior lime plasters. You can do the Moroccan style tadalakt in the bathroom. It's wonderful. It's a wonderful natural material. It's also quite high embodied energy. There's a cost associated with buying the lime. Personally, it's caustic. It's not something you would want to work with day in and day out. I wouldn't. Maybe some people are not as sensitive as I am. And for that reason, I'm hesitant about getting excited about an earth like a natural building technique that uses lime as a bander for the entire wall, like Hempcrete. It's very caustic. So we have multiple people have told me that have built Hempcrete buildings that they wouldn't do it again because it was so caustic. It was harsh to work with. But in the right places, like exterior lime plasters, interior tile, wonderful. And that's what we do commercially. We've just actually lime plastered a Hempcrete building. So, really wanting you to understand the nuance between using lime for specific things and using lime as a binder. It's two different things, two different conversations. What was the name of the man working with the pellets? Mark Fielding. I will pop a link to his website into the comments. I just covered it. Okay. Yeah. So Mark Fielding, Posy, yeah, it's nice, nice work. But also on that note, of the Posy and the building with the pellets, the idea to prefabricate panels with pellets was great. Like he even had like a manufacturer going where they made the pellets and then the panels, the pellet panels, and then the assembly happened out of panels. The whole prefab idea. It's where it's all going. But and it was all reclaimed materials. So like the materials were super cheap or free, but then it required so many fixings to put them together and make them safe. The cost in the fixings was substantial. So we did one building in the system, and even though pretty much all the materials were free, it was not a cheap building because of all the fixings. So it really pays to do a proper cost analysis to be able to compare if you want to go as cheap as possible, cheap and good quality as possible. You'd be surprised what you come up with when you do the comparison. Okay, so I think this brings us to the end of the questions. Look at us, that was a long session. Thank you so much for all the beautiful questions and comments, and I hope to see you again tomorrow. And I'm looking forward to hearing in the group, your rationales on which techniques you are going to go with. And we'll see each other again tomorrow for floor plans. And just wanting to say, you should be receiving emails. If you don't, let me know, please. Okay? Have a wonderful day, evening, morning, wherever you are. If you're watching the replay, drop in more questions. Like I'll come back to this and answer questions. So don't be shy about it. Okay. Thank you so much. Bye, everyone.